Good morning, class. This is a correction from my last example. So I found a math error in there, so I'd like to go through it quick here. I apologize for this. It's Monday. This is new to me. Okay, so in this previous beam example, where I found my math error was when I was figuring out the weight of the beam and getting it in pounds per inches. Instead of multiplying it by 12, I need to divide it by 12 because feet is on the bottom here. Feet has to be on top here, so I got to divide by 12. Okay, so I get the weight of I'm sorry, not the weight of the beam, but the weight of the live load in pounds per inch is I got to divide this by 12. And then the weight of the live load plus the dead load is 10 plus 50 times 8. Plus the weight of my beam, and then divide that by 12, I get 43. Okay, so now when I corrected that, when I put this number in here, I was really confused with why I was getting very large numbers, because obviously it was this number right here. This was wrong. So I get 1.35 inches, which is still less, or which is still greater than the 0.93 inches, which is allowable. Okay, and then on the live load plus dead load, I get 1.7 inches, which is less, or which is greater than 1.4 inches. Okay, so what do I do according to that, to the flow chart? Okay, so if I look here, okay, I did not meet deflection, so I select a larger beam. So what I decided to do is just double it up, because I can make the moment of inertia bigger. Okay, double the moment of inertia. Okay, when I double the moment of inertia, what am I doing? I'm doubling the weight of the beam. Okay, however, like I previously mentioned here, I necessarily, okay, when I double the moment of inertia and I double that means I double the area and I double the required section modulus. So the added section modulus required due to basically I am doubling S add and A add. Okay, so if I look at that, so I'm doubling this. Okay, so if I add S total, I add 14 to that. Okay, I'm still under one beam. So 249 inches plus 14 is 254, which is still less than that. Okay, so now if I double this, so 3.6, let's make that 4, so I add 8. Okay, A total. Okay, so I go 8, so I add 65 plus 8, and I'm at 73. So I'm still under, I'm not, I only doubled these values, so I'm still under a single load, but you still should check it according to the design chart. So I'm still okay by doubling things. So I'm not increasing the weight of the beam so much that my deflection or my bending stress and my shear stress is going to be is not going to meet. Okay, typically when it's deflection, we're okay, so I don't have to worry about that step. All right, so now if I go back here, so here's I just basically did that in my head, S total, S required. You probably would want to show it. All right, so now let's go to our deflections. Okay, so I go to, so I'm going to use 2 of these. Okay, here's my double my moment of inertia. Okay, now here's my new live load plus dead load. Okay, so here's, this number did not change. Okay, here's the double moment inertia. Now I am under my 0.93 inches. Okay, because this has not changed. And then here's my new load because I doubled my weight of my beam, right? Because I got to add the weight of the beam. And then I'm 0.89 inches, which I'm less than 1.4 inches. Okay, so going back to here, right? So I didn't meet it at first. No, selected a beam. I doubled the weight of my beam. I checked my S add and A add. I checked my S total and my A total. I still met that. Okay. So my deflection now, or that's okay, yes. Now my deflection meets now, so now my analysis is complete. So finding my math error, this problem makes more sense. I apologize for that. So this is the end of the corrected lecture. So thank you, and good luck, and let me know if you have any questions. Please email me, or okay, thank you.